today we start the funnest part of geometry to me. Although this is related strictly to algebra today, we're looking at algebraic things. We are going to start the process of doing a proof, which is not just a statement of what you did, but beside it we're going to put a reason of why you could do it. So we need to go back and talk about the properties that we use for equality. And the addition property of equality, kind of in words would say whatever you add to one side of an equal sign, you have to add to the other side. So if you had a statement that said this, A is equal to B, the addition property of equality says A plus C is equal to B plus C. And you can see that what I added to one side of the equal sign, I added the exact same thing to the other side. And you use that property all the time when you're solving an algebraic equation. We're just going to make you put a reason beside it. What did you do? All the properties of equality kind of look the same. If it starts out with A equals B, what do you think the subtraction property of equality says? A minus C equals B minus C. Whatever I subtract from one side of an equal sign, I have to subtract the same thing from the other side. Multiplication property. If A equals B. By the way, if you ever see this arrow like this arrow implies the word then. If A equals B, then A times C equals B times C. And again, you'll notice that whatever I've done to one side, I've done the exact same thing to the other. Division property, exactly the same. If A equals B, then A divided by C equals B divided by C. Whatever I divide one side by, I must divide the other side by. Sometimes you see this one written this way, but understand that it does mean the exact same thing whether it's written in fraction form or whether it's written with the division symbol. Does everybody recognize that these are the properties that you're using to solve an algebraic equation? You've been solving them right along, but you've not had to put an explanation beside what you've been doing. Everybody okay with the properties of equality? Can I go to the next slide? These property of equalities you may not remember. We don't use them as often. The reflexive property simply says A equals A. The symmetric property says if you know A is equal to B, then you know B is equal to A. It's like looking at a line of symmetry. Whatever was on one side could be folded over and put on the other side. the transitive property, if A equals B, and B equals C, then A equals C. And what you should notice here is that where this statement stopped, this statement started, and in the end one, it just goes from outside to outside. It stands to reason if A is equal to B and B is equal to C, that A is equal to C. The substitution property says if A equals B, then any A can be replaced by B. And you use this a lot when you're actually combining like terms. And just kind of as an example, if you had something like this, x plus 2 plus 3 equals 2x. Underneath it, you would have written x plus 5 equals 2x. What property would allow me to take 2 plus 3 and replace it with 5? And it is substitution, because 2 plus 3 equals what? Which means any place I see 2 plus 3, I can substitute that 5 in its place. So we use it all the time. We've just never named it that way. Everybody good with this slide? Okay. So, examples. We are simply going to name the property that justifies going from the first statement to the second statement down here. So they're saying 6 plus 2 equals 8, and 8 equals 4 plus 4, so they want to go to 6 plus 2 equals 4 plus 4. What property allows me to state that? This is transitive. It's one of the few properties that you see that kind of has three pieces to it. It has an A and a B and then a C part. Example 2, 5 equals 1 plus 4. But in the second part, they want to say 1 plus 4 equals 5. Which property? This is the symmetric property of equality. And I'm just going to abbreviate it. If x equals 3, 5x equals 5 times 3. This is substitution. X minus 3 equals 7, so x equals 10. Somebody said it. This is the addition property. Remember, these are all properties of equality. 6x equals 18, x equals 3. It's what? It's the division property of equality. If, for me, I'm okay if you write this, what I've got up here. You can abbreviate. The only thing that I'd say be careful about abbreviating is substitution. Make sure that it's obviously substitution and not subtraction. You just can't write SUB, in other words, because then you wouldn't know which one was which. Everybody good? 1 through 5. Okay, the distributive property does state this. A, parentheses, B plus C equals AB plus AC. This is a property that goes both directions. You can say if A parentheses B plus C, then AB plus AC. You could also say if AB plus AC, then A parentheses B plus C. You can go either way. It also works when they're dealing with subtraction. This would be AB minus AC. A proof, and I've printed that definition in there for you. A proof is a convincing argument that uses deductive reasoning. Deductive means that it has to have some kind of explanation that goes out beside it. A two-column proof is simply a list of statements with their corresponding reasons. Most of the time when you're asked to prove something, it'll start out just like this. Given this statement, prove that x equals 3. The first statement of a proof, 9 times out of 10, probably 99 times out of 100, is that given statement. You've got to have a place to start. You start with what they gave you. Well, if I looked at this, the next thing I'd want to do is subtract that 3 from both sides, which gave me 2x equals 6, the subtraction property of equality. The next thing I'd want to do is divide both sides by 2, which is what they did, the division property of equality. Keep in mind, this is what you've been doing for a long time now, and the only thing you've really added to it is what? The reason.
So this is basically like justifying your answer?
That's correct. It's exactly what you're doing. In other words, you're writing something where anybody that didn't know anything about algebra would be convinced that you've got the right solution because you've been able to explain exactly how you came up with it. Everybody good? Okay. On this next one, they gave me 4x plus 1 equals 16. They asked me to prove that x was equal to 3. In this first statement, what's my reason? It is given. They gave it to me. It's given. To get from the first statement to the second statement, what did I do? I distributed. That's going to be reason 2. What did I do for number 3? I subtracted the 4 from both sides to give me 4x equals 12. And the last one was division property of equality. By the way, on the next example, I would say that there's actually a step that they should have included in here that's not in here. I really say that statement 1 should have been xy equals 21, and the reason beside it should have been given. And the reason I say it should be there is because there's no logical way for them to get from 1 to 2 unless you know this value. This reason doesn't come from this given statement. It comes from the picture, and it's going to take a geometric reason over here instead of one of the algebraic ones. Does anybody know why I can state that xz plus zy is equal to xy? It was a postulate that we talked about probably in 1-4, if I had to guess at what section it came out of. Maybe 1-3. Segment addition. The segment addition postulate says if you take part of a segment, you add the rest of the segment, it's equal to the whole segment. What property then would allow me to take xz and replace it with 2x plus 3? This is substitution. Everything from here is algebraic. The only statement that was geometric was the first one that was here. What's the next one? Distributive. What's the reason for number 4? That's what a lot of people say, but it's not addition. This is substitution. Remember, in order to be addition, it has to be added to both sides of the equal sign. Here, I just took 2x and 3x, and I said I know it's equal to 5x, so I replaced it with 5x. And what's my last reason here on number 5? It's subtraction. And it did cut off a statement. They wanted me to prove that x equals 3. What would be the reason? Division. Lexi. Sebastian. By the way, if yours has a score on it and then that score was crossed out, it's because I changed how I graded something. I had to go back and fix this class. It affected some, but not all. Elizabeth. Danielle. Jason. Check Carl. Emily. Preston. Jackson. Christian. Hannah. Niall. Rhiannon. Danny. Caroline. Sarah. Nick. Lanisha. Joseph. Julian. Carolyn. Casey. Jesse. Lillian. No, is that right? Can't read it. Sierra. It's a C. Andrew. Matthew. Sarah.
Which one?
Sarah C. Did I already give you one?
Yeah.
Better look at it. Wrong Sarah. You might be happier with the grade. I don't know. I don't know which one was which.
Yeah, I am. Yeah.
Sarah with a P. Sarah. Just like. And last but not least. Just real quick, want to talk about the most missed question. Most missed question was number 4. There's P and Q. Here's why it was missed. It said E was a midpoint. People drew the picture like that, but they didn't mark that it was a midpoint. Make sure that you put those marks in the picture. It's going to tell you what you have to do next. It said PE was 5x minus 1. How big is this? You don't know that if you don't mark that it's a midpoint. And I'm going to tell you that I saw some silly answers. And the reason I say that they're silly, is there any way that part of a segment is equal to the whole segment? Not now, not ever. There were a lot of people that set these two equal. If you set those two equal, you actually came out with a segment length that was negative. Is distance ever negative? No. Make sure that you mark the picture. I'm going to tell you the questions that I saw missed on today's assignment came from this word. Bisect and midpoint, kind of the same thing. One deals with an angle, typically. One deals with a segment. But what do you know from both of those words? That it cuts something into, and instead of using half, I like this. 2 equal pieces. And the reason I don't like half is because people then don't know what to put here. And some people, when they put the number over here, they took this, they subtracted this, and they got 2x plus 5. If they did that, and they tried to add these two pieces together and set it equal to this, you know what it's going to give them? It's going to give them all real numbers. Because you've used the same piece of information to calculate it. If you did this, what do you have to do with these two pieces? Set them equal to each other. Make sure you mark your picture.
I just have this negative, and I bet you I'll put it negative. Yeah.
Alright.